Good morning. I'm gonna run and get coffee. I'll be right back.
We'll be here. Okay. Recorder is going. That's all good.
Good morning.
Good morning.
I'm at the t-shirt for the occasion.
Very nice.
I had to grab a couple of these before Tabular went down.
Do you call it went down?
I just did, but I mean, yeah. I guess that's not quite appropriate. But it is no more. I get to be an engineer again, which is nice. All right. Well, it's almost time to get started. Any objections to getting started on the highlights, and then we'll go. I think with multi-table transactions, we'll probably have plenty to talk about today. All right. So first off, in the Java highlights, 1.9 is released and out there. There's actually a lot of stuff that I didn't realize was going into 1.9, but I'm really excited about. So things like all of the variant changes are already in 1.9. So thank you to Ajantha for getting that stuff in. Also, the core changes, and I think even the readers for at least Spark row, non-vectorized Spark reads are also in, so you can start kicking the tires on that. I don't think that we quite got the merge and update changes in, but it's at least at a point where you can start looking at, create a V3 table, write a couple of commits to it, and see those row IDs and sequence numbers coming through. So that's really cool. And then there's all the other stuff that I'm no doubt forgetting about the 1.9 release. There's a link to the milestone under releases if you want to check out more. But thank you to Ajantha for managing that release, doing a couple of RCs and getting it out the door. It's always nice to have releases, less than 3 months apart. We love having, a quicker release cycle. So thanks. Next, there's a heads up here. Peter, is that from you? Do you want to talk about that one a little bit?
Basically, I did a little bit rewrite of the data file rewrite and compaction stuff. Now the planning is in the core, and this planning is used by the Spark data file rewrite actions. And this is what finally get in. So we will actually remove the old APIs from the, it's already deprecated in 1.9, and we will remove it 1.10 from the core. And the guys, I have seen several features which are being added to the Snap, the data file rewrites, and I would like to highlight this for the guys who are working on that they want to move the changes to the new API. I already pinged them on the PRs and whatnot. But this is another place I'm trying to highlight this.
It sounds like this is moving some of the logic that we used in Spark to do incremental rewrites, rewrite planning into core so it can be reused across projects. Awesome.
Yes, and Flink is getting there as well. So we will have the same planning used in Flink and Spark.
Awesome. Well, that sounds like a good feature. Thanks for putting that in there. All right, next up, I wanted to say a big thank you to Aihua, who has been rounding out the rest of our variant support. So in the last few weeks, he added readers and writers for arrays, which we had initially left out to simplify just the logistics of getting this stuff in. And he also got through all of the additional variant types that were added in the upstream project into our implementation. So things like nanosecond timestamp, time, and what was the other one? UID. So the types all went in. So now the types within a variant basically match all of the types that we support as the Iceberg table types, with the exception of binary and fixed are basically the exact same thing in a variant because there's no consistency of length across types. So every fixed value is inherently a binary and vice versa. So thank you, Aihua. Did you want to say something? I saw you unmuted.
Yeah, sorry, I think I have a problem in connect. Yeah, I think we are getting to fully support the variant. I think we still have a little bit left, like support a variant array on the metadata side and on the Spark side. That's gonna be our next task. So after that, I think we can fully support variant. But of course, thanks a lot for Ryan to review and give a lot of good feedbacks.
Yeah, it's really great to see variant, basically, I would say complete. It's not plumbed through all of our object models, where we, for example, we don't have Flink support or Spark support because those engines don't actually support it. We're thinking, like Aihua said, of going and adding the ability to read variant columns just as binary or as a tuple of metadata and value binaries. We need to think through how exactly we're exposing that and whether that is consistent with how we want to work with this data in the future. So we'll be releasing that, but the direct object models, Avro, internal, and Iceberg generics all work natively with variant. So, and that'll, I'm sure, come up in our V3 discussion. So thank you for all your work there. Next, I want to highlight that the row lineage changes are complete. Well, not complete. We're still working on getting it plumbed through all the object models. But we have support in for Spark 3.5. So this was led by Amog, who basically figured out a elegant way and not a giant ugly way of updating the merge code in Spark 3.5, which actually lives in Spark, to make it all work. Basically, what we're doing is we're waiting until the plan is aligned and we've got consistent assignments, and then we're just adding a couple extra assignments to the end, and then doing some other, hacks a little bit to make sure that Spark considers the plan still resolved. But it's working, it's tested, it's good to see that going in. We're next working on vectorized readers and things like that. But I think that the major milestone here is that we have this end-to-end example of how row lineage should be working. The core changes to metadata are in, and we've, I think, proven out the feature overall. So thanks to everyone who's been working on this. I know, Russell has done a ton of work as well, especially on core changes and reviews. So really great to see that going in. Next, I want to move to Flink, which we added 2.0 support and dropped 1.18 support. I always love celebrating when we remove support for things. So that's really great to see. Thanks a lot there. So now we support 1.19, 1.20, and 2.0. And thanks to Maximilian for contributing that support. We've also been seeing, even more migration to JUnit 5. I actually hit this when I was working on porting readers and writers to Spark. The tests had to change between 3.5 and 3.4. So it's really great to see, the migration continuing to happen and not just letting the 3.4 sort of drop off the map. And then lastly, there were some fixes to timestamps in view history where we were incorrectly committing or not forwarding the version timestamp into table properties correctly. We were sometimes taking the version timestamp when you set the view version if the version was not new. So if you were to reset the version of a view back to something old, you would actually get the old timestamp for when that version was committed, which wasn't correct. So thanks to Leon for noticing that and implementing a fix. Next, we've had quite a few minor spec changes to either clarify or get us ready for this V3 release. So first of all, thank you for everyone who took a look at the vote to clarify our struct field conflicts. We had a situation in which you could have a struct field that had its own struct default with its inner fields. And then you could also have default values on those fields themselves. And the question was, when do we use one versus the other? How do you reconcile those? And when do you need to update the outer struct value and so on? This was just added complexity that we didn't need. So we got in a fix to the spec that says structs are just basically a placeholder to say whether or not the struct is null. And all of the field values, when you create a default struct, come from the fields themselves. So that, I think, was a good thing for making it easy to making it easier to implement. And also, it's not a one-way door. So if we need those additional complexity or to have field level defaults at the struct level, we can do that in the future. We also clarified the row lineage requirements to relax a lot of the constraints there, basically allow implementations to assign row IDs that as they see fit. So if you've done the work to determine this is how many data files are being assigned, you can be more exact. On the other hand, if you want to just be safe and conservative, you can always account for the number of existing and added rows. So that was a good clarification to get in. Another thank you to Aihua for getting in the spec changes to support lower and upper bounds for variant values. So this is the format that we use for the binary lower and upper bounds for a variant column. And it specifies how to encode lower and upper bounds within a variant bound for each field within the variant if you have consistency in types. Then Paco got clarification in for the multi-arg transforms. And lastly, the geospec simplifications went in to essentially make our geotypes behave like other types, more like decimal than a complicated field type. I'm actually, I think everyone has probably seen the email on the dev list. With the changes in the last week, I think that we're at a point where we can very seriously consider voting and adopting the V3 changes, because we have implementations that prove out the design and implementation of, the spec changes that we want for basically all of V3. that's a really amazing place to get to. And with that, I will hand it off to Kevin, maybe for Rust, or Fako. Who wants to do Rust?
Yeah, I'm happy to do it.
Good. Right.
Yeah, so for Rust, we finally have the Puffin writer and the Puffin APIs public. Thanks for working on that. I know it has been part of the sync a couple of times, but he broke it very nicely in small pieces. So thank you for also doing that. Made the reviews much easier. We got support for removing schemas by Loic, which is from Rising Wave. We got support for bucketing on timestamp nanos by Jonathan. And we got like SQL logic tests run by Data Fusion. For those who are not familiar with SQL logic test, it's a very nice way of testing like the output of like a SQL query. So yeah, it's very elegant, I think. So if you're interested in that, please take a look at it. For Iceberg, we got like a Kerberized Hive client fixed by Kevin. Thank you, Kevin, for working on that. I always envy people who have to work with Kerberos. It's always painful. But you also got like good tests in there, so hopefully it won't break again. We got the introduction of App Manager, which is like a concept that we have in Java, and we also want to port that to Iceberg because it actually separates like all the out stuff from the actual REST logic. So yeah, very cool to see that happening. Right now it's mostly scaffolding, so if you're interested in working on that, please jump in. We got the ability to pass an existing client into the catalog by Connor from Daft, which is also a nice feature. We got the Upsert, which has been released by 0.9, that didn't support like having complex types in your table because we do like a join to the deduplication, and in Arrow joins cannot have like complex types in that, so we switched to another way of doing it, which is a bit slower, but yeah, at least it works. So I'm very happy by the fix by Koen. We had an issue with writing decimals. We always write them as like a fixed binaries. It was discovered when we did like a reboot of Iceberg Go. So we also backported this fix into Iceberg. And I also want to do a big shout out to a report of an issue. So it was not actually a pull request, but someone reported that in a very special situation, we did not write like a field ID, but it's very helpful to get this fixed. And it's also part of 0.9.1. So yeah, please make sure to upgrade. For Go, shall I continue or do I have Matt on the call? I can continue. So we got commit support for Glue by Leon. We got like the fixed encoding of the partition spec by Arnold, which caused like an issue in ClickHouse. And we got also the ability to register tables by DAO. And we also got like, and that's my personal favorite, like testing against the REST catalog integration test and the REST fixtures that we have now in the Iceberg project. So that's always also cool. Super Plus, a lot of activity there. And also this list is so long because we skipped like the sync during the Iceberg Summit. We got like the virtual classes for the catalog table transaction. We got the file reader interfaces and the metadata readers and writers. We got the whole expression stuff by Ying. We got the sort orders, snapshots, metadata structures by Young One, and we had the partitioning and transform being added by Guo Tao. So there's a lot of activity going on Super Plus. If you're interested in that, make sure to catch up. So now is the time to steer in a specific direction. Yeah, it's very interesting to see like all the stuff that's happening there.
Awesome.
So jump off the release. Do you want to do that, Ryan?
Well, I wanted to talk about finalizing V3, but it's a great time to highlight 3 releases: Iceberg Java 1.9, PyIceberg 0.9.1, and it sounds like definitely update because of the field ID issue, and then Go 0.2. Really great to see all the releases happening. So thank you guys for working on all that. And also validating releases and testing them, and like it's really critical to have the community come together for those releases. So thank you. I also want to talk about V3 finalization. As I've sort of done through the highlights, I think that we have gotten implementations that prove out basically all of the newer V3 features. We also have a lot of a lot of it just built out in terms of like default value support across Flink and Spark and all readers, which I think is a prerequisite as well. We want that we want to either fail when you try to use a V3 feature or to correctly use the feature, and we are, I think, at that point. So I wanted to just raise here that there's a discuss thread ongoing for what we need to do to get to the point where we are comfortable releasing V3 and adopting it formally as a community. Now, my perspective on this is that we should probably do it sooner rather than later. To me, and this is up for discussion, which is why I want to raise it here. What we want to do is de-risk the spec and make sure that we're confident that it is correct and thorough and implementable across implementations. And then we really want to move to move to get it out, because we really can't have people relying on it as a canonical spec and implementing it and working towards this in earnest until we actually finalize it and say, this is the set of things that you're going to need to support, and this is how to support them. So I think that we have reached that tipping point where we want to, really do our homework and make sure that we are confident that we have de-risked the changes. But at this point, I believe that we are there. So I wanted to, open up the discussion on, when do we want to do this? Are there any remaining concerns or open items? That sort of thing, both here as well as on the dev list.
I have one question. Do we have any compatibility test between the languages, like the Python, the Rust, and Java? The one is writing to V3 and another one is reading to V3. Do we build into that kind of compatibility test?
We do have the ability to run those sorts of tests. I don't believe that we are currently running them, except for in limited cases. Fako, you probably know best because you've been working on the additional types and default values in the Python implementation, right?
Yeah, that's correct. So what we use in Iceberg is the Iceberg REST fixtures, the doc container that actually runs like a REST catalog. This also supports we have a nightly build that's every night for main. So if stuff is changed in there, you will see it directly the next day in your own project. But we also have like a version on the Iceberg Java releases. And what we use in Iceberg is also like just a Spark that also contains like the Iceberg jar to generate like deletion factors, these kind of things, just to test in Iceberg if you can read them correctly.
Are we going to only support Python and Java for the V3, or should we, enhance that support for other languages such as Rust or
Well, so we won't be in a position where we can guarantee V3 support across everything. So it is going to be up to implementations to declare when they have V3 support. And I would probably not even say that we're going to declare full V3 support in the Java library in 1.10. We'll need to see. The milestone that I think we want to discuss right now is whether we've gotten the spec to the point where we think that it is something that we can finalize, right? That is saying we're not going to add new things to it. This is what needs to be implemented so that we can get started on those implementations. If we were to try and, wait to get all of the implementations fully supporting V3 before releasing V3, that turns into kind of a catch-22 where we say, well, we can't really declare support for V3 until this thing supports V3, and in the meantime, new features are coming in, new types and so on. So I think that again, reached that tipping point where we want to start getting the spec finalized as soon as we are confident that it is correct and not going to change.
Yeah, sounds good. I agree with you.
Dan?
Yeah, I just want to add on to that there are definitely things beyond, just the across languages. Even within the Java implementation, we know that ORC is not up to the level that it can actually support v3. So we've had a couple of discussions about this in the past. And so I don't think that precludes us from adopting the spec because we do have implementations with Parquet that do work, Parquet and Avro. But it is something that, later, if people want to contribute and bring that up to what's necessary to support v3, we can do that after the fact. The same thing is true with the other language implementations. If we gate on everything, we'll never be able to close on another version of the spec.
Maybe having a page describing what is supported in where would be useful when we are starting release after we release v3.
Yeah, we actually have that docs page that shows like the compatibility matrix, which is actually pretty good. We probably need to update that, and it'll get a little bit more complicated with all the v3 features. But I think that that's actually a really good use case to show people like, that want to contribute or are interested in like, hey, can I move to v3 because I'm using this tool set? They can kind of reference against that to see if they're ready and contribute where things are lacking.
Yeah.
Yep.
Yeah, good call out. Thank you.
My only feeling on this is I want to make sure we have at least one all the way through implementation. It doesn't have to be for all file formats or whatever. I just want, when we say that it's final, we know that like the Java library can do everything that's in the v3 for a Parquet table. But that's my only threshold before we really say we're done. Because I don't, the thing I'm worried about is getting into a situation where we're past and we have to do something like data sequence numbers again. Where like we had it out, we said this is it, and then we realized we basically made it so the Flink couldn't run in production, and we had to kind of go back and add some things.
Well, data sequence numbers weren't for Flink running in production. They were basically to make it so that we could resequence data files that were added but contained only older data, and so didn't need or could still have deletes applied for them. So I don't know that we necessarily I don't know that we necessarily need to sorry. I don't know if that's a good example, but to your point, I believe we are at that point with the Java library. Now, we don't have, notably the variant support like Aihua was talking about. There's no way to plumb that into Spark as a variant because there isn't Spark support. Same thing with Flink. So I'm not inclined to wait until Spark v4 arrives or a version of Flink arrives where those types exist upstream. We could certainly discuss doing that, but I would much rather get the spec out for the implementations that do already support those things. I know there are commercial implementations that do support the variant type in their engines, and I would love to get that out there for BigQuery and Snowflake and those sorts of things. The one exception I think to your threshold of Parquet support across the board, I think would be the Spark 3.5 support for vectorized Parquet reads. Amo, I believe, has a PR for that right now. So we would have that coming in 1.10 release.
But we still have a row-based reader.
Yes, we do.
Yeah, it's just so again, like it's not that we don't have something that shows the path. It's just that we haven't plumbed it through all the places, and we know that we can't do that. And that's true in prior, like even v2, we didn't have everything plumbed through everywhere, which like equality deletes is an example that is still somewhat bifurcated and never got like fully implemented across everything. But at the same time, I think in this case, with the data types, we're fairly confident with where they stand. And then the other areas where there are significant changes like DVs, row lineage, we already have implementations for. So those ones would be the riskiest ones, and we have implementations. Talent?
I have only a concern as an open source, the user, any vendor is supported feature. If there is no open source implementation, I believe we should not, claim that it is a V3 spec is final. This will introduce the vendor lock-in. Like, if BigQuery support the variant and the other, the engines are not supporting the variant, and the customer or users, whatever, they write their data, then they cannot read from the Spark or Flink. Then this is not the good, the experience for users.
So you can write and read variant data in Iceberg today. You just can't do that through the Spark engine. And so, like, I don't think that we should gate the V3 spec on a particular engine release in order to get that out, right? Like, the fact that Spark v4 is, hopefully coming in the next few months, but should we wait for Spark v4 to get out, back with the Spark v4, add Spark v4 support and then get our v3 spec out? Again, from a perspective of ensuring that the spec is correct, which I think is, what we want to do, I don't really see the need for that, especially given that this support came from Spark itself. So we know exactly how, this support is going to look. It's just a matter of passing it through.
I see. Yeah, if you are confident for that, I don't have any objection. But if we are not confident about, we will have that support on open source, then we will just introduce some kind of higher barrier to, the user to use that specific type. Like they have to implement their own readers using the Iceberg rather than Spark.
Yeah, I see no blocker to supporting Spark v4 as soon as it's released.
Sounds good.
Okay. Thank you guys for the discussion here. I don't want to take too much time on v3. There's also a discuss thread open, so please raise any concerns or issues that we want to tackle before voting on adopting the v3 spec. Please do open it there. We want to make sure that everyone is comfortable and that we have consensus around moving forward before we move to a vote. So thanks a lot for taking a look at this area. Okay. Next up on the agenda, I want to quickly highlight Péter's format API PR. We're trying to get reviewers to go take a look at that. I know that I need to go take another look as well. So thank you for the reminder, Péter. We'll get that in, reviewed. The next thing that is up is the design doc for interval types in Iceberg.
Okay, so
yeah,
I can take that down. So hey, I don't think I know too many people here. It's my first Iceberg meeting. So I'm Narain. I want to give a big shout out to Russell as well for sort of helping advise on this proposal. But kind of to give some context, I'm working on kind of supporting interval types within the context of the Snowflake engine, and I kind of wanted to propose an Iceberg kind of interval implementation. So interval just represents the duration of time. It doesn't really have a start or end point, so it just defines the span in between. So for instance, 1 year and 5 days, 1 year and 5 months, or kind of 2 days and 3 nanoseconds. So for context, there are just 2 different genres of interval if you look at different implementations across engines. So in Parquet today, intervals are a fixed length byte array of like 12, and they're really stored as 3 kind of little endian unsigned integers. So you have months, days, and milliseconds. And that implementation varies pretty significantly from intervals implementation in a lot of other different engines. So for instance, in Spark, you have kind of year-month intervals, and you have date-time intervals. The concept there being that because different months have different numbers of days, Gregorian calendar specifics, we want to be able to separate the two. So daytime intervals would consider any range from days, hours, minutes, seconds, all the way up to whatever kind of scale you prefer, whether it's nanoseconds or microseconds. And this is going to be the case as well in Trino, as well as what's defined in ANSI SQL standard. So in SQL standard, you have kind of year-month intervals and daytime intervals. So the high level of kind of the recommendation I propose for interval types in Iceberg is to follow the SQL standard representation, and it would look something like this. So you'd have two primitive types, year-month intervals and daytime intervals. For year-month intervals, this would really be a signed integer representing a number of months. So this is kind of the physical representation. It would correspond to a Java long. I think based on conversation in the doc, it seems like the preferred option is to use a 4-byte signed integer. So this is similar to what Spark does, as well as Teradata. It covers a range of years that's, I don't know, 100x higher than that of human history. So I think that's pretty sufficient for most people's cases. And then for daytime intervals, a signed value representing the number of nanoseconds. And this would sort of correspond with Java decimals. None of this is set in stone at the moment. The kind of goal of this proposal is to really hear the community's thoughts and generate feedback on this data type proposal. Because some pros and cons. As a pro, this is compatible with most of the interval database vendor implementations. So Oracle, Teradata, Databricks, Spark, Snowflake, and Trino. As a con, it doesn't map one-to-one with the Parquet implementation I referenced earlier. So Parquet really represents things as months, days, and milliseconds. It kind of mixes these year, month, and daytime intervals. I know there was some discussion on perhaps deprecating that representation of interval within Parquet and moving towards a representation that is more aligned with kind of the rest of the engines kind of discussed here. But I just wanted to kind of bring this up and hear folks' thoughts on this. I know some folks have commented already. Thank you for that. And see if anyone has kind of strong opinions here.
I'll jump in. Thank you for doing this. I like the direction of adhering more to the SQL standard than with Parquet's kind of wacky interval type. I'm not a huge fan of big byte array types in Parquet. So I think cleaning this up in both Parquet and Iceberg at the same time makes a lot of sense. And also thank you for being responsive to the feedback. I know Matt jumped on it pretty early and had some good comments, and it's great to see the doc updated. So thanks. Any other comments?
I think one thing I wanted to mention is anytime we add a new data type, there are other feature considerations, such as transforms. Maybe there are others, but I think those will be good to add to the list as well. How does partition transform work with this? That's the only one I can think of on the top of my head, but for every new type, there's a list of features that we probably have to support. I'd take a look at Geo and Varia and see what are missing from this proposal.
Yeah, that totally makes sense, Kevin. I think kind of the next step here is kind of if most folks are aligned on sort of moving towards this representation, create more of a complete design, like you mentioned. So kind of covering some encoding and decoding, functions, expressions, and what you mentioned as well. So yeah, that's pretty much it for me. Thanks.
All right.
Could you? I missed that interval type, the document. Can I also review it? At least could you give it a little bit time before the design? Then I can also check that how it's compatible with our implementation.
Yeah, absolutely. I think the doc is linked on the agenda, so feel free to just jump in. Yeah.
Thank you.
Awesome. Thank you. All right. Next one is probably the big topic. Multi-table, multi-statement transactions in Iceberg. Who wants to take us off with this?
Hey everyone, I'm Jagdeep. I'm brand new here, so thank everyone for giving me some feedback on my proposal. Yeah, I should acknowledge there are a lot of comments on my document. I still need to go through them and clean it up and reply to some comments and modify the document accordingly. But the main reason I created this proposal is we're looking at how to support these kind of transactions for our customers. I'm from Amazon, right? When multiple engines are operating on a set of tables in a catalog, and a user wants to start the transaction and maybe run read queries and things like that, while other engines are modifying the tables, right? So the main thing in my proposal is how to enable catalogs to provide like a point in time consistent snapshot across tables, right? Yeah. So I just look forward to feedback from the community. I know we got some early feedback that maybe we don't have a lot of users running these kind of queries today. And I think what I also want to learn from the community is that some kind of use case we want to enable in the future, and how people think about that.
I'll jump in because I have some thoughts here. First of all, I would say the snapshot consistency of reading tables is, I think, a probably later step, right? Because what we primarily care about is establishing some isolation level for commits. And for, I think, most use cases, repeatable reads is a very reasonable trade-off, which is what we would basically get out of the box. I think if you look at when you would not need repeatable reads, you're talking about use cases involving transactional commits to multiple tables that you're using transactionally in a downstream write, right? So something like I write to a users table and I write to a signups table, and I know that the foreign key relationship always matches across those because I wrote them transactionally. And then I need to consume those consistent states across tables, in another transaction. So I think that narrows the use cases for the read snapshot isolation. And without having gotten to, serializable or snapshot isolation on the commit path or the commit time, it seems a little far out there. So I would say at a minimum, it seems like we could work on this in parallel with the, just basics of transaction semantics in Iceberg, right? Just being able to do the analysis of, what changed in this table that I read? Would that change have affected the final commit? And if not, commit. Same thing with like a commit time snapshot isolation, just not looking for changes that would have affected the rate. Then once that is in place, I would say it makes sense to go and take a look at, further read isolation levels and what we need there. I'm also, I believe the approach is to start a transaction and start plumbing through transaction IDs in the REST catalog. And I don't think that actually works, because the clients still need to be able to select, the clients still need to get the entire table state, and choose the point in time at which to read those tables, which means we have to annotate for the clients the sequence of events in the catalog somehow. And I don't think that transaction identifiers actually help us get to that goal. Sorry, that was a lot, but those are my thoughts.
No, that makes sense. I'm not taking notes because I will go through the recording and then write down notes. Yeah, no, I think that makes sense. The reason I use transaction identifiers is I know that catalogs would need some kind of sequencing about commits across tables. I was thinking how to hide how catalog does it from the clients, right? Like,
but how would you do that? Because the client needs to know which version of a table to read, and it also needs to know about the future versions of that table. So it's not like you can send the transaction ID to the catalog and then have the catalog say, okay, I understand this transaction ID. I'm going to give you just commits older than the point in time where that transaction started. Because the client actually needs to know, in order to implement the serializable isolation for the commit, the future commits and what occurred in those commits in order to know, is it even worth continuing with the transaction at this time? Or would future commits already blow up the transaction and create conflicts?
So I'm not sure if I'm agreeing with Ryan and we're just thinking of things in a slightly different way, but the way that I would think about it is in context of what we currently have for our transaction endpoint. Right now, we break all commits up into requirements and updates, right? And if I think about how that would extend to multi-table transactions, you define a transaction level, and that boils down to certain requirements of tables that are read during that transaction, what is updated, and how fine grain you get depends on, well, how much detail do we want to put in those? Like a very coarse grain would be, I read this table as of this snapshot, it needs to not have moved, right? So if you can say that for all the tables that you read and all the tables that you wrote to, like that's very coarse grain transactions. Nothing can conflict because I said the world has to be in the same state as when I started this, and I can commit to it. But then we can refine those. We can say, well, I read this table with this filter condition. That needs to not have changed, right? So if we refine our requirements and our updates in a way that we can associate those with what is necessary for a specific level of isolation for a transaction, then we get to a point where a client can represent this, client can validate it, and catalog can validate it.
Well, so Dan, I think the challenge is the client needs to be able to select snapshots of tables that are consistent at the snapshotted point in time. And in order for the client to be able to express the requirements, like table A needs to be at snapshot whatever, table B needs to be at some other snapshot, it needs to know that table A and B, there was some point in time where those two snapshot IDs existed and were current. And so, like, in order to do that, we have to have some global sequencing of snapshots across all tables and communicate that to clients so that they can determine what they're going to read, right? Because in order to say a table A is changing over time, there are two ways to limit changes to the point in time that you're interested in for read snapshot isolation. You can either annotate the global sequence number, global catalog sequence number, and send that to the client. So when the client starts up, it loads its first table and says, I'm going to read everything as of global catalog sequence number, whatever. And the client does that filtering. Or you can, I think this is what the suggestion is, you can go request using some identifier given to you by the catalog, request the state of the table at some period of time, at some time. But the problem is, if you're loading a table at some time, right, then you're not seeing the latest in that table. You could, you're not seeing that there are future commits that would already invalidate that transaction. So like, I think that the only solution here is the first option, which is you have some method of annotating each snapshot with the global sequence number determined by the catalog.
I'm not convinced of that. Like, well, so one thing like hidden in there that you're trying to solve for is we want to identify early when a transaction could not complete, right?
Mm-hmm.
So if we were completely optimistic in our transactions, you could go through a large transaction and fail at the very end, even though
True.
there was something earlier on that you could have identified that would have conflicted.
But you're also getting into complexity, because now we're saying that the catalog does need to understand how a snapshot corresponds to this global sequence number across tables, and then filter the metadata based on that.
But there's also a couple other things in there that I think we're making assumptions about. Different databases have different ways of when they pin the read time of a table. Some do it at the beginning of the transaction. Some do it based on first access.
But
we need to define what we want it to be.
We're talking about read snapshot isolation. So I think we all agree that repeatable reads, you get whatever state it was at when you first loaded the table. That is doable without any modification to the API. I think what we're saying is that we're concerned with use cases where you want read snapshot isolation. So all of your table states come from a specific point in time. And that gets back to my earlier point, which is, when do you need snapshot isolation for your reads? That would be when you have cross-table consistency, and you need to guarantee consistent states across your table reads, which doesn't even matter until you can transactionally commit to multiple tables. So I see this as a future feature that we can continue to debate. But I do think that there is a eventual need for read snapshot isolation.
Yeah. I think the other point that I actually need to clarify better in the email is, like, there may be transactions which don't even have writes, right? Like someone just wants to run some reports. They start a transaction and it's going to be a long running transaction. So they may not care that some tables have changed and what has changed, but they just need a way to read consistent snapshot isolation at some point in time across tables.
Assuming that those tables were committed through transactions.
Yeah.
Right. Because if you're not committing with a transaction, then there is no way to guarantee consistency across tables.
Yeah.
So I think the important thing is to get started on repeatable reads, and using the existing multi-table commit API to basically implement multi-table transactions to create situations in which we need the snapshot read isolation. And I would also say that the transaction ID approach, I don't believe gets us the snapshot isolation that we're interested in, because we still need the client to understand what versions of the table exist before or after that point, right? So the client needs to load a table, get all of the snapshots for that table, know which snapshot to read and to put into its requirements, and also how to validate that its assumptions have not changed after that point. So to me, like, the best thing to do would be, rather than introducing a transaction API to start a transaction and introducing state on the catalog side, it would be to expose the global transaction or global sequence number of commits across tables somehow at the snapshot level.
For that, I would like to add that when we were writing Hive transactionality, there were plenty of read transaction, and creating a transaction ID for every read was time-consuming and causing issues on the Metastore side. So I think Ryan's solution that creating a sequential number event numbers on the catalog side would be a bit easier on the catalog level if we can make sure that a single catalog serves all of the requirements.
Well,
Yeah.
I think that having a global ID across all changes to tables is a necessary precondition to having snapshot isolation on reads, right? Not all catalogs would even support this. But what I'm envisioning is essentially when you load a table, you would be able to identify, a list of the snapshot IDs in the table and then the global clock or global sequence number when those snapshots were created and actually committed. If you were to do that, then you could do this all client side.
Yeah, no, that makes sense. I need to do some more homework after thinking through all this. I would say, one small thing is like if we do that, the only snapshot isolation we can implement is time of the first table load. Or I need to think about how do we translate it to time of the transaction start, right? Like if there's the
Okay. I mean, to do that, then what you would probably want to do is simply have a way of getting the current global sequence number from the catalog.
yeah, as long as the user types begin, right? I think that makes sense. I think
it's also worth questioning, is there a significant difference between time of start of transaction and first table load? Like, practically, what scenario would there be where that would result in a different outcome?
I agree with you there, Dan.
I don't know how you can have a transaction that's going to somehow have a different outcome if you say start a transaction, whatever you determine that to be. That's an arbitrary decision at that point versus the time of first table load.
I mean, you could definitely have a different state. You're just more likely to fail the transaction on a conflict.
Yeah. Well, and so the difference, like if you think about like serializable transactions, which is what most of the relational industry cares about. A lot of the implementations do time of first table load, largely because the way you think about it is like if you were going to execute that transaction instantaneously at the point of commit, would all of the requirements still hold? And that would be true even if you loaded the table a little bit later than when the first table loaded.
But Dan, that's the concern of the write isolation. The read isolation, you still need to be able to guarantee that you have consistent states across tables as you read them. Right? So it's sort of both. If I have consistency across tables, then I need to guarantee that I read a consistent state across tables A and B, and that there were no changes that would affect the outcome of the transaction at the time that I committed. So I think it's best to think of this as the write isolation level, which we would have as essentially serializable or something weaker. That means essentially use whatever I read. And the read isolation level, which is somewhere between repeatable reads, use the same version across all reads to this table, or snapshot, which is a guaranteed point in time.
Yeah, I mean, thank you, everyone. I think I need to go back and rethink the proposal in terms of global sequence numbers and rework what that would look like.
Awesome. Well, thank you for bringing it up. It's really great to see this work, progressing. So thanks for taking it on. All right, we have 2 more things and 0 minutes left. Russell, did you want to give a quick shout out for the Iceberg Summit videos?
Yeah, I just want everyone to know that I made the playlist on YouTube. I have 22 videos up. That means I still have to do like 40 or something. But I will try to get those done today.
Awesome, and thank you all for coming to Iceberg Summit. It was a fun time, and really amazing. I thought that was one of the best run conferences I've ever been to. So thanks a lot. See you guys in 3 weeks. Have a good one.
Yeah.